Okay, with that, Joseph,
Okay.
it's your show. Thanks, Jeff.
All right. Thank you, Martin. Thank you, Jeff. So this is, I hope, so I'm not sure you can actually see my PDF. I have shared it, but it doesn't seem to appear, at least on my side.
Yeah, we can see it.
Oh, you can see it. Okay.
Yeah.
So this is the memory alignment ticket, ticket number 121. It's been discussed twice now with some great feedback. I tried to incorporate what we discussed in Chicago at the face-to-face. I restructured it a little bit so that all of the main definitions of the alignment requirements and the info keys are now in Chapter 8 for MPI allocate, mem allocate, MPI alloc mem, sorry. And then in the window chapters, we only reference them. So I thought I'll just start reading the changes from the beginning, basically. So we start on page 364. Here's a paragraph that I inserted. By default, the allocated memory shall be aligned to at least the alignment required for load store accesses of any data type corresponding to a predefined MPI data type. The info argument may be used to specify a desired alternative minimum alignment in bytes for the allocated memory by setting the value of the key MPI minimum memory alignment to an integral number equal to a power of 2. An implementation may ignore values smaller than the default required alignment. The last sentence there was quite some discussion around it at the Chicago meeting, mostly because the implementation can actually completely ignore the key. So I think there was some consensus that we should have this hint, mainly to make sure that applications don't try to rely on the behavior that may change in the future. So just setting the info key to 1 and I don't actually know why we did that.
No, the other reason this is important is there may be some limitations on the underlying system allocator that prohibit fine grain alignment, and so we never want to obligate anybody to do something that's impossible.
Okay. Thank you. The rest of the changes here are cosmetic, so it just changes the structure a little bit and says that the info keys corresponding to the places where memory should be allocated are implementation dependent. That part was in there already. I just had to change this sentence a little bit to make the paragraph flow better. Okay, so this is the part for MPI alloc mem. Is there any questions on this part? Is that clear?
You have one minor typo on line 18. Maybe it's a formatting.
There's a T missing. I think that is from the highlighting the macros that I used in LaTeX. Oh, yeah, I'll fix that. Okay, so going on.
So just a quick question, why do we do this with the integral power of 2? Just because we don't think there will be any other alignments that are useful?
Well, Martin, that's actually required in C11. The C11 aligned malloc says it's illegal to use a non-power 2.
Okay. All right. I don't think it's a harm, anything. It's just, it's a minimum alignment, right? So the MPI could always choose the next next larger power of 2 if it wanted to. But okay.
Yeah.
That's fine.
Yeah, the question is whether that's, I mean, that's, if we have this in there, is it erroneous to pass non-power of 2 values?
Yeah.
Okay, so then the MPI implementation has to check for it. Is it mandatory to signal an error in that case, or can it just silently round up?
I think it's implementation defined, and what happens if you specify an info key that's not conforming to the standard.
Okay.
So technically an MPI is allowed to crash at that point, I guess.
Is that behavior that we want?
I think that's fine. I personally think that's fine.
Okay. Okay. Okay, moving on. This one is in the chapter for MPI bin allocate. Here it basically references what we just discussed in chapter 8. The default memory alignment requirements and the MPI minimum memory alignment info key described for MPI alloc mem in section 8.2 apply to all processes with non-zero size arguments. So if you have a process that does not allocate memory in the window, it has a 0 size, there can't be any alignment, and otherwise the memory of every process should be properly aligned. Any questions for that? Is that clear? Okay, so I guess not. Moving on, the next change. So this is the contentious part that we had a long discussion for in Chicago. What happens with shared memory windows? And again, it starts by referencing the part in chapter 8. For contiguous shared memory allocations, the default alignment requirements outlined for MPI alloc mem in section 8.2 and the MPI minimum memory alignment info key apply to the start of the contiguous memory that is returned in base pointer to the first process with non-zero size argument. For non-contiguous memory allocations, the default alignment requirements and the MPI minimum memory alignment info key apply to all processes with non-zero size argument. So, and there's an advice to users that outlines the problem with shared memory windows. If the info key alloc shared non-contig is not set to true or ignored by the MPI implementation, the alignment of the memory returned in base pointer to all but the first process with non-zero size argument is unspecified, and on process I larger 1 depends on the size argument of the previous processes 0 to I minus 1. It is thus your user's responsibility to ensure correct alignment for the data types to be used in the allocated shared memory through the choice of the size argument on each process. So for contiguous memory, the MPI implementation can really only ensure correct alignment on the first process that has non-zero size argument, because it has to be contiguous, and on any other process, the alignment or the position where the memory for that process starts is dependent on the sizes of the previous processes. And that is a problem, and I think that's a problem that most people might not be aware of, so that's why we have this advice to use it.
So the other possible solution here is so that if a user specifies alignment and they specify a size of the allocation that's an integral multiple, then the way those elements will be divided over the processes will be such that it will be element aligned, right?
You mean that the memory is actually not contiguous anymore, but we add padding?
No. It is contiguous, but I'm saying let's say the alignment is 16 bytes, okay?
Yeah.
And if you ask for 1601 bytes, then you're going to have a problem. But if you ask for 1600 bytes, then everybody gets 100 elements, and it seems, I guess, or whatever, displacement. If your displacement is a multiple of your alignment, then you will get aligned in every process, right?
Mm-hmm.
So why wouldn't we just address, either we should put in an advice, add this to the advice to users, or we should set it as a restriction that if you specify alignment, that I guess displacement is tricky because displacement propagates through to the RMA calls, and I don't know, we don't want to break existing usage, but I think we should potentially do something that if you do the right things with displacement, then you will be okay.
So you mean, so this is basically the consequence of it's just writing it in verse, or I'm not sure I understand.
Yeah, I mean adding to this advice to users. So this is the warning, but if we add that when the displacement is a multiple, an integral multiple of the requested alignment, then the allocation base in every process will be aligned, because obviously it will give one element to each, and therefore the alignment will be preserved.
Okay. Yeah. So having both the negative and the positive.
Exactly. I mean, if it's advice, we might as well give both ideas.
Okay. Yeah, that's fine with me.
All right, I'll go punch this into your ticket somewhere.
Okay. Thanks. Any other questions, comments?
I think this thing with the ignored is kind of weird now, though, right? Because you as a user can never know whether the MPI implementation ignores it or not. So basically, for you, it has to be always true that you can never rely on this, right?
Yes, that is a problem. That's a problem with the info key.
Right.
But didn't we add the ability of info keys to be assertions? I thought we had that feature in MPI 3.
As far as I know, we had discussions. So I had discussions about it with Jeff, whether we should make the alignment info key mandatory. But it doesn't seem to really be a good use case for it. But I start feeling that the alloc shared non-contig might be a good use case for mandatory info keys, because that is a significant change in the semantic of the allocation.
Yeah, I mean, the other way to look at this, because we've always sort of had this, cowardice about info keys, is just expect that good implementations will not treat them as hints, and users will stop using people's implementations when they are not implementing a quality library. I mean, that sucks when you've got a closed system that the vendor doesn't make it possible for anyone else to do it. But at least in MPitch and OpenMPI, it's reasonable to expect they'll do the right thing or be shamed into doing so after the fact.
problem here is that it's not, well, you can figure out whether it did the right thing. But it's not that as easy as checking for the correct alignment, for example. So you have to look at whether the memory ranges that you get for all the other processes. So it's sorry.
Yeah. Yeah, the non-contig one though is a performance optimization. I mean, if alignment is required for correctness, you can check for it, and if it fails, you can free the window and try again with padding and do the alignment yourself, right? So we, in theory, nobody can be prevented from writing correct programs with this. It's just stupid.
Yeah. True. I mean, so Martin, you said that the part about the info key being ignored, do you think that's necessary? Or I don't think we mentioned that anywhere else explicitly. Well, I mean, it is mentioned that info keys can be ignored, but we don't make this distinction anywhere else, I think. Is that too weird?
No, I think it's not the mentioning is not weird. I think we actually should mention it. I think that's good. It's just the consequence is odd, right?
Yep.
And I have a good and as Jeff said, we can do everything with it technically, but basically you can't really anything do with it. You can work around it, but you can't do anything with it because you never have a guarantee. But I don't have a better idea either, to be honest. There's really a problem in how it was written originally.
So Martin, why don't we just go back and fix it and just put in fix wherever it says it can always be ignored, and say some info keys can be ignored, some can't, and they'll say whether they're ignorable. Because I mean, we know obviously there are cases where we have to let people ignore them, but there are cases where it's clear that we shouldn't, it should be a non-fatal error to ignore them. I don't know why we haven't fixed this after like 4 years.
That's true. It is actually still backwards compatible because it changed for the implementation of the user, right?
Yeah, we're not going to break anybody's code by giving them stronger guarantees.
Right. I think that's not a bad idea to suggest that and see what the implementers react to that. I probably would suggest to Joseph though to make it a separate ticket.
Yeah. Well, and the other thing, I mean, on this specific, we'd end up needing we'd end up with a site over every specific info key, and we could start out with, okay, they are all still optional, and then we could add a ticket to make for each one we wanted to make not optional.
Right.
And I honestly, I can't imagine any reasonable implementer objecting to most of the ones we want to make required. But I haven't gone to the forum in a while, so who knows.
So one of the things I thought of we added MPI assert as a prefix for info keys. Why not have a prefix for required info keys and then add an info key for non-contig that has a prefix? That makes it easier for implementations to check the required info keys and just error out if they don't know them. And then we could phase out the old info key maybe, or just leave it side by side.
So we had this discussion about renaming info keys before. And basically, what it came down to, that people at the end wanted to have some kind of alien system for the info keys. I actually don't know where that went, to be really honest. So I think that just renaming them or dropping them at some point, I think nobody liked that idea. So that may be hard. But could still mean that for future things we follow that suggestion that you had and have an MPI underscore required or something like this for those kind of info keys. I think that's worth bringing to the larger forum and discussing it. We don't have that many people here today. Does anybody else have an opinion on this? Particularly if there are any implementers in the room? I guess all the implementers are fine with it that we have on the call, right?
So I just joined and I did not fully catch that question. What
The question is, should we make some of the info keys that are now optional, at least on a case-by-case basis, mandatory, particularly the one with the contiguous one? If you say you wanted, if you wanted non-contiguous, that you would guarantee that this couldn't be ignored anymore.
I'm not sure I'm following, but anything that, if we're talking about mandatory info keys, I think that that's more of a user thing, right? I don't know. Implementers we can do whatever we need, but if we're telling the users they absolutely have to supply info keys, that seems.
No, it was more like that. Some info keys is whether the MPI can accept or not accept to implement. Right, so they can be ignored. So you, the user, don't know if you put an info key in whether that's going to be taken or not.
I see.
And the non-contiguous, perhaps if you take a look at the screen, the advice to users that Joseph has there, the first sentence is really awkward and really not helpful because of that can be ignored by the implementation. That's how we got onto it.
Well, I'm only one implementer, so
Well,
take my input as a grain of salt. But I would think that I still prefer the option to ignore info keys.
okay. So Jeff, do you want to argue against that?
Yes, it helps if I argue with the unmuted. The compromise position, since we have been making a more nuanced view of errors, that is, allows for, last time I checked, we have errors that are fatal and errors that are not fatal, and we actually could distinguish between them. One possible solution is if we made failure to implement an info key a non-fatal error, then because we've had this problem of, well, we talked about, you ask for info key, well, does the implementation attach the info key and then ignore it? Like there was a lot of ambiguity of, could a user even truly determine if an info key was in effect, which obviously in alignment it's pretty obvious you could tell, but if we just had error keys like info applied but not in effect, and info key dropped, or whatever the right words are, then we could at least have an unambiguous mechanism for users to know what the implementation did with an info key that wouldn't also technically put the library in an undefined state, which is of course the whole thing with error codes in the past.
Yeah, if I could just return a null pointer in the case where I don't want to deal with the info stuff, that I would be okay with that. I know that's not really, we don't have that definition yet, but that would be, more aligned with memory allocation functions,
Well, but I'm thinking POSIX memline returns an error code. Yes, you can use null, but it's also better to look at the error code, right?
Yeah, I suppose. I think C11 aligned alloc just returns null. Oh, well, it returns null if you don't use a multiple of some.
Yeah. Okay. No, makes sense. Anyways, I think this
But
is,
either way,
we're now a field of this ticket, but I think I really think, Martin, that the forum should. We've been talking about this a lot, info keys crap for like, I feel like 5 years, and we should just solve it.
So I think since we're going to read this ticket anyway next time, so Joseph, why don't you just, I try to remember it too, but let's just remember to have the discussion after the ticket is read in the forum and kind of collect more data on the suggestion.
Okay, so should I prepare some sort of proposal, or should we just have a whole discussion about this in the context of this ticket?
If you could have a couple of slides, I would really suggest to decouple it because you don't want to derail the discussion on this particular ticket. But if you could prepare a couple of slides, I think that would be really helpful.
Okay.
Thank you.
Okay, I'll do that. So there is 3 more places here, 2 more. So one is adding that new info key to the list of info keys, and then one is the changelog entry, and that's all that is to this ticket. Are there any grave objections to how this is handled now? Okay. Then I would put this up for reading again in Zurich, and hopefully this can go into 4.0, because it's really been annoying for us as a user.
Yeah, I think this addresses the concerns we had in Chicago.
I'm curious, is this fixed in OpenMPI now? I know that was the origin of this whole ticket. Is this implemented?
There is a pull request, but that is labeled for 5.0 as far as I know.
Right. Okay.
Yeah, I don't know, maybe I can push for it a little more. I didn't try to get it in earlier.
No, I mean, it does have a simple workaround, and if somebody needed to deploy it for people that don't know it, you could always do it in PMPI. You could intercept and pad. So.
Yeah.
Okay. Yeah, I was just curious because it seemed like something that should have been fixed instantly, but.
I totally agree. Okay. So if there's no other questions or comments, there's a second proposal that I wanted to talk about. I don't know if we should wait this half hour until it's 11, or if we just continue, Martin.
Yeah, I'm thinking about it too. I was wondering, is anybody in particular missing that you think would call in just for this topic?
Well, Jeff is here from the RMA people. I was hoping there would be 1 or 2 more, but.
Well, if you hope there would be more, then we probably should wait until 6 because that's how it's announced on the website. It's kind of unfortunate for the rest of us, but it would be useful.
Yeah, I guess so. I'm gonna. Intel rarely votes no, and I will strongly support this within Intel. So Intel will support this unless something weird happens. I think that from an RMA working group perspective, I don't know. A lot of the people that are supposedly in the RMA group are pretty inactive at this point. So I think the feedback that really matters is the implementers. So obviously, I think Ken can look at this. I don't even know that MPitch has the issue. Joseph, did you try? Does this work with MPitch and it's only Open MPI where it's busted?
You mean the alignment?
Yeah.
Yeah, MPitch seems to be fine. Yeah, we only saw it with OpenMPI. Although I have not tested pathological cases for Win shared with MPitch. I no, I haven't.
Okay, Win shared is probably slightly more of an issue, but I don't know. I think, Martin, I don't think that this is RMA specific. I think this ultimately just comes down, because it's part of AllecMem. It's something that has to be handled as a case in the implementation, the allocator, which is.
Okay, yeah, sure. I think what you was talking about at part 2 of the virtual meeting, which is RMA.
Oh, I'm sorry. I didn't understand.
I think we all concluded we're done with the AllecMem, and we all agree that this is the right thing to push forward, right?
Yeah.
Okay. So the question is, should we wait? So we could either wait for 20 minutes, or we could do it speculatively, and you can start, and then if somebody really joins at 6, you may have to repeat it.
That works for me.
That may be the best thing to do, and if really somebody joins that wants this discussion on worst case, we have to have a second reading of the whole thing, but then if not, we have speculatively concluded early. What do people think? Is it acceptable to everybody?
Yeah, that works for me.
Okay. Then go ahead, I would say.
Okay, I'll change the share. I guess I have to. Okay. Wait a second. Okay. Okay. So this is a ticket that I wanted to have a first reading in Chicago, but then there wasn't enough time, so we just dropped it and decided to go for a virtual meeting. At the core of this is that, as I wrote in the ticket, currently in MPI RMA we don't have any way of enforcing and ordering except by waiting for the RMA operation to complete at the remote site. And there may be cases where you want to have an ordering, but you're not interested at this point in actual completion of the operation, and you can basically save some latency or reduce the latency by using features that the underlying network provides in order to in order to add what's usually called fences into your stream of operations and rely on the network to do the ordering without waiting for remote completion. So unfortunately, MPI Win fence is already taken with a completely different semantic. So my proposal is to call it MPI Win Order. And MPI Win Order takes 3 arguments. One is the order type that is described below. It's the types of accesses to order, the rank in the target window, and the window object. The text reads: MPI Win Order ensures that RMA operations initiated before the call complete at the target before operations initiated after the call by the calling process to the target rank on win. The ordering extends to local load store operations if the provided rank is the rank of the calling process in the group of win, or if win is a shared memory window. The call is a local operation and may be used with both active and passive target communication. I should add that this is really, I forgot to say that, this is really the first time this is being read, and I'm just hoping for some feedback to change it for maybe Zurich or even after that. The order type basically specifies what kind of operations should be included in the ordering. This came out of a discussion in the RMA working group, where the desire was expressed that we should differentiate between read and write operations. The value provided in order type controls the types of operations to be ordered and is one of the following integer constants. MPI win order read. The ordering applies only to read operations, for example, MPI get. All previously initiated read operations will complete at the target before read operations initiated to the same target following this call. MPI win order write. The ordering applies only to write operations, for example, MPI put or MPI accumulate. So this, in general, this includes both atomic and non-atomic operations. All previously initiated write operations will complete at the target before write operations initiated to the same target following this call. MPI win order depend. The ordering applies to all data-dependent read and write operations accessing the same or overlapping memory regions and can be used to ensure read after write, write after read, and write after write ordering. Accesses to non-overlapping memory regions are not ordered. So with MPI RMA currently, without any flushes, non-atomic writes are not necessarily executed in the order in which they were issued at the origin. So this would ensure writes and reads to the same memory region are ordered. And MPI win order full. The ordering applies to all types of operations. Any operation initiated before the call completes at the target before operations initiated to the same target after the call. There's a rationale describing this. Ordering of any of the above operation types will likely require special treatment by the MPI implementation if the target rank resides on a remote node. For shared memory communication between ranks or local window memory accesses, however, certain optimizations may be applied based on the types of ordered operations. While MPI win order full may require a full memory barrier, no additional instructions may be required for MPI win order depend on CPUs that guarantee ordering of data-dependent loads and stores, which is basically, from what I understand, everything x86 and ARM, and only, I think, DDEC Alpha had some issues there. So if you're writing to a rank that is on the same node, calling MPI win order with this flag shouldn't cause any overhead except for the call itself. Similarly, on some architectures, ordering independent stores may be more efficient than ordering both loads and stores. On x86, from what I've read, a write barrier is cheaper than a read barrier. Expressing the intended types of operations to include in the ordering may thus yield performance benefits in some situations. However, MPI win order full can be used in all situations where ordering is required. Advice to users: The return of a call to MPI win order does not guarantee the completion of outstanding RMA operations, but instead can be used to enforce a partial ordering between RMA operations initiated before and after the call in the ensuing flush and synchronization call. So even, okay, there's an advice to implementers. A conforming implementation of MPI win order may wait for the completion of all outstanding RMA operations at the target rank before returning from the call. However, implementations should try to minimize the amount of work performed in this routine and instead attempt to provide as much asynchronicity as possible. So even if the MPI implementation decides to implement MPI win order as a flush, this is not guaranteed to the users. There are some examples later on. I can jump to those. Are there any questions on the text here? Anything unclear so far? What I want to achieve with this function? There's no reference implementation at the moment. I'm thinking about putting something together in OpenMPI. I have had an application where I was desperately wishing for this feature to be available. So this is where this came out of. Okay. If there are no questions, no comments, I'll skip to the next part of the change. Okay, so here's an example. The following example illustrates the usage of MPI win order to explicitly order read and write RMA operations and avoid intermediate flushes. Process B may periodically check for the state of X1 and consume the variable X0 if an update is available. So process A, the window location is hosted on process B, and process A does a put of a value into X0, issues an MPI win order to order writes, and then puts the signal into X1 and then performs the flush. And on process B, the value of X1 is read, and an order for read operations is performed, and then the value in X0 is read and flushed. And if the first get yields 1, then it's guaranteed that the second get yields the value V. To ensure that the signal put into X1 is written at the target after the value V is available in X0, the ordering of writes has to be enforced on process A using MPI win order. Similarly, reading the value X0 on process B must happen after the reading of the signal variable X1 to ensure consistent results. Without the calls for MPI win order, the put and get operations may happen in any order. Alternatively, the calls to MPI win order could be replaced by calls to MPI win flush, which might increase latencies on both processes. There's the second example. Again, the window location is on process B, and process A performs RMA operation. The following example illustrates the usage of MPI win order to explicitly order RMA read and write operations from the same origin to the same target to ensure reading of consistent data after a put. Process A puts the value V into X, then issues a MPI win order with MPI win order depend, gets the value from X, and again issues an MPI win order with MPI win order depend, and writes the value into X, this time a different value, and then performs a flush. And this should guarantee that the get yields V and X contains U after this sequence of operations. The ordering type MPI win order depend is used to ensure that the get reads the value of the previous put. Without the ordering, the get may return either U, V, or any value previously present in X. The reason, or for us, this is interesting because we are implementing a PGAS abstraction based on MPI RMA, and we basically have no control over what the user does. And this is probably a sequence that a user directly using MPI might not want to do, but for us, if we can ensure the ordering without actually having to do the flushes, that may help us reduce the latencies.
So I have implemented ARM-CMPI and OSA OpenSHMEM over MPI, and in ARM-C we have basically TSO semantics, and so we just promote put to accumulate with replace and get accumulate no op, which I get has performance implications, but from a remote, from the network standpoint, adding the atomicity overhead isn't the problem. It's more the static routing or whatever it is going to be. So, but I'm really curious to know what the implementation performance differences are here, because if this is just a different way to express something, but it gets implemented the same way, then it doesn't have a lot of value. But if somebody can say, oh yeah, with verbs or whatever it is, that it makes a big difference, then it's much more compelling.
So okay, so you're interested in a reference implementation?
Well, I'm not interested in a functional reference implementation because we can do that today, because
Yeah.
I mean, that's trivial. What I'm interested in is and I don't care if it's actually code is written and working. I'm more interested in a protocol by protocol analysis of the different flows. So, verbs, Cray, DMAP, or Eugenie. I don't think Ethernet matters, and then both weak and strong shared memory. I think it'd be really useful to actually show that and say, okay, this is going to be, the following sequence of MPI operations maps to the following sequence of verbs primitives, and then somebody can say, oh yes, I see, we're going to get XYZ upside on verbs if we have this.
Okay. I'm not an expert in this layer.
Yeah, no, I understand, and I'm not suggesting that you have to do it. I think one possible thing to do is work with somebody who is an implementer. You could also potentially sort of provoke somebody into doing the analysis by claiming something that is potentially false and making them prove you wrong, right? So just assert without evidence that it's either totally different or exactly the same in verbs, and then wait for somebody to correct you with the right information. Anyways, that's to me what's really important here is and I think actually the pencil and paper analysis is more important, because a reference, let's say you implement this in MPICH or OpenMPI, neither one of those implementations has a super great RMA. They're both pretty good now, but there's so much overhead in a lot of the RMA implementations that you might not actually see the difference, or you might not see the difference at the scale you measure. But that doesn't mean that just because RMA implementations today have overhead does not mean that we should not care about performance in the definition of the specification. So I think looking at, assuming some theoretically optimal implementation that doesn't have a bunch of software overhead, what would it look like?
Okay. I can probably try to come up with something for verbs and put it into the ticket. Maybe that triggers others.
Yeah, and so Jim Dinan might be able to help here, because this is obviously very similar to what Shmem does. The other thing you could do in theory is you could actually get this question either directly or via a surrogate onto the Open Shmem list and ask those implementers what the difference between put, get, and fetch and set, which are atomic put and get, and then what's the overhead of Shmem fence.
Yeah. Okay.
Because I know at least in some implementations, Shmem. So in some implementations of Shmem fence is a no-op, and in other implementations, Shmem fence is a quiet. And that's actually kind of an uninteresting pair of implementations, because quiet's either super expensive or pretty efficient if the network is designed for Shmem. And then, of course, the no-op case basically says, oh, yes, we've just decided to order everything, so, of course, we don't have to order it explicitly.
Yeah. That was the main reason why I put it in there, to be able to differentiate between this case of writing to the same memory location and writing to different or reading from different memory locations, because on Shmem, from what I understand, it should not. You can get around the memory barriers.
Yeah, no, I don't. I know we've discussed it, and I think there's a Shmem proposal. Literally, I got an email about it this morning related to ordering. So, but actually, you might. Do you have a Cray machine in your center?
We still have one until the end of the year. Yes.
Is it Aries or Gemini?
It's Aries.
Yeah, I actually, if you were to write the code in Shmem for Aries, so Aries, I believe the implementation of fence is quiet, but it's quiet based upon polling of a local counter. And actually, maybe you might want to write it in DMAP, because I think Torsten and I discussed either the PGAS languages or Shmem, maybe both, have too many memory barriers in them. So DMAP won't have the memory barriers as far as I know. And if you need help writing DMAP, I could send you some example code. But DMAP's probably your best bet for analyzing the relative behavior of this stuff.
Okay. If you could send me some code, that would be great. If you have it at hand, otherwise,
yeah, I mean, it's just code on GitHub.
Okay.
Sorry for the interruption.
No, it's valuable. Thanks. I'm fishing in dark waters here. Not my area of expertise, but I want to push this. Cool. Oh, now someone joined.
So who just joined?
Okay, maybe.
I think it's Artem, but he is not connected to audio yet. That's the problem.
Okay.
Okay. So perhaps you have to. We'll see what he wants to hear, but we may have to repeat some stuff. Speculation failed. But in this case, so I have a question to the example that you have with 1114. And I'm not a big RMA person, so I'm just really more of curiosity. But if I understood your proposal right, is if you want to apply this to the whole window, right? To every operation outstanding on the window that is either read, write, or depend, right?
Yes, to the same targets from the same origin. Yeah.
Right. So the advantage over the encoding flush is really just that you're restricting the type of operations, not the locations of the operations, right? Because the flush would do the same things that it targets every single operation, or is there another difference that I'm missing?
Well, the difference that I'm hoping for is that with a flush, you have to wait for the operation to complete on the remote site. Whereas with this, if the network's properly supported, you can immediately issue new operations without having to wait for them to complete.
Okay, got it. Okay. And then looking at the example again, so the X is actually a window in this case, right? So when you do the put X, the put you mean with the X location in the window, and the win order call you mean the whole window then?
Yes. Yeah. Yeah. There's no restriction on the position in the window. Yeah.
Okay. Because this is pseudocode, right? And that's why I got a little bit confused, because it doesn't match the arguments that you have. The arguments are not the same type sometimes, things like that.
Okay. I can check how it is done. So here MPI win post is done on B. Okay. I will check how it is done in other examples and maybe adapt it.
Yeah. What tripped me off that X had two different meanings, right?
Yep.
Okay, but I think I know what you mean now. Okay. All right. So
still the example might not be clear enough really to capture what it means. I mean, if we have to ask what the example really means to understand what the function that depend is really about, it might not be really the right way to put it in the standard for people to really understand what happens. I'm confused with the example with the depend, the order depend thing. Because as Martin said, X here relates to the window and the window location, it seems. So. Okay.
Well, that is something that I can probably fix somehow. If that is the problem, like differentiating between the position in the window and the window itself, that's an easy fix. If the sequence of operations and why we want to do this and what the outcome is, if that is confusing, then maybe I should change the example.
Some of the examples in the RMA section are a little bit verbose, and I think maybe you want to put some other arguments in the put and get, and to see, okay, it's the same window, but it might be different, and no, either same address, but not with the same number of elements, or different addresses, but which overlaps to say, okay, these are orders.
Okay.
Just put, I don't know, x2 with 4 elements and then x0 for 4 elements. They're overlapping, so they will be ordered. I think it will help really to get the text for order depends. Saying that the example might be a bit confusing, I think.
Okay, I'll try to come up with a more clear example. Thanks.
Thank you.
Okay. I know if Artem, you just joined. Do you have any questions? We decided to go ahead after the first part, so maybe you've missed most of the reading. Should we repeat?
Did we start at 9 my time, like at the top of the hour, or I was late?
No, sorry, yeah. Go ahead.
Said, yeah, you were in time. We just finished the other part earlier, so we decided to speculatively go ahead, and if somebody would dial in top of the hour, we would just redo some of the parts, because otherwise we would have had just a gap of half an hour in between. The other reading all before was just faster than expected.
Okay. So I'm not familiar enough with proposal, but we definitely need to get familiar with it. So I think I'm going to read the ticket on my own, and then maybe comment on the ticket, because I missed the reading, and I need some time to get involved.
I mean, we could just read the actual API again. I mean, we were talking a lot about the examples, right? But I think it may be useful just to go over the actual core of the ticket. That may be helpful to start the discussion.
Okay. Yeah. Sure.
Okay. So I'll repeat the reading of the API definition.
That would be great, I think. Yeah.
Okay. So MPI win order takes 3 arguments. The order type, which specifies the types of accesses to order, that is described below. The rank in the target window, the rank of the target in the window, and the window object. MPI win order ensures that RMA operations initiated before the call complete at the target before operations initiated after the call by the calling process to the target rank on win. So the ordering always only affects operations from one origin to the same target. The ordering extends to local load store operations if the provided rank is the rank of the calling process in the group of win, or if win is a shared memory window. The call is a local operation and may be used with both active and passive target communication. The value provided in order type controls the types of operations to be ordered and is one of the following integer constants. MPI win order read. The ordering applies only to read operations, for example, MPI get. All previously initiated read operations will complete at the target before read operations initiated to the same target following this call. MPI win order write. The ordering applies only to write operations, for example, MPI put and MPI accumulate. All previously initiated write operations will complete at the target before write operations initiated to the same target following this call. MPI win order depend. The ordering applies to all data-dependent read and write operations accessing the same or overlapping memory regions and can be used to ensure read after write after read, and write after write ordering. Accesses to non-overlapping memory regions are not ordered. So this is something that today we can get from atomic operations, but is not covered for non-atomic operations, and with this option to MPI win order, you would get the same behavior for non-atomic operations. MPI win order full. The ordering applies to all types of operations. Any operation initiated before the call completes at the target before operations initiated to the same target after the call. By the way, feel free to interrupt if you have any questions, if anything is not clear.
So I actually have a general question. Can you provide the context where this is a problem?
Yeah, so I was implementing an application or a use case with atomic operations. It was mostly atomic operations, but also non-atomic operations, where it was important to ensure that there's a certain ordering of operations at the target. And I realized that I have to perform a flush every time, and that basically after every operation I have to wait for the operation to complete at the target, which always takes a microsecond or more than that. So the idea is that if the network supports it, it could be done more efficiently by just inserting a fence in the operation stream and then continuing with the next operation without actually having to wait for the completion, right? And it could be that the implementation just decides to make it a flush. In that case, there's no win, but on networks and systems where that is possible, I think we could see some improvement in latency.
And do we have nowadays networks that supports that? I'm not sure if we support that.
From what I've seen from the verb specification, there's a fence.
Yeah, in verb, yeah, right. In verb, you're guaranteed to have order if it's the same QP. Yeah.
I did some testing of OpenSHMEM on InfiniBand, and there definitely was a difference between using quiet and fence. So that seems to be supported, but I'm not.
Yeah, right. But this only applies to the overlapping memory regions. And like currently MPI doesn't tell you like if you do it in specific order. MPI standard doesn't imply that the actual RMA operations will be completed in this particular order. Is that correct? And that's why we need this clarification.
Yeah. Oh, sorry. I was thinking about your Mellanox head. Yes. So right now in MPI, non-atomic operations are never ordered unless the ordering is enforced by a flush. And atomic operations are only ordered for overlapping or say memory regions. So we cannot order atomic operations to different memory locations unless we perform a full flush.
Okay. I see.
Okay. I think I stopped at the rationale. So the rationale, ordering of any of the above operation types will likely require special treatment by the MPI implementation if the target rank resides on a remote node. For shared memory communication between ranks or local window memory access, however, certain optimizations may be applied based on the types of ordered operations. While MPI win order full may require a full memory barrier, no additional instruction may be required for MPI win order depend on CPUs that guarantee ordering of data-dependent loads and stores, which is, from what I know, true for x86 and ARM, for example, and not true for DEC Alpha, if anyone's still using that. Similarly, on some architectures, ordering independent stores may be more efficient than ordering both loads and stores. Expressing the intended type of operations to include in the ordering may thus yield performance benefits in some situations. However, MPI win order full can be used in all situations where ordering is required. Advice to users: the return of a call to MPI win order does not guarantee the completion of outstanding RMA operations, but instead can be used to enforce a partial ordering between RMA operations initiated before and after the call in the ensuing flush or synchronization call. Advice to implementers: a conforming implementation of MPI win order may wait for the completion of all outstanding RMA operations at the target's rank before returning from the call. However, implementations should try to minimize the amount of work performed in this routine and instead attempt to provide as much asynchronicity as possible. That that clear?
Yeah.
Okay. So, and then we had two examples. I think this one was less contentious than the other one. The following example illustrates the usage of MPI win order. To explicitly order read and write RMA operations to avoid intermediate flushes, process B may periodically check for the state of X1 and consume the variable X0 if an update is available. So the window is hosted, or the window location is located on process B, 2 elements, and process A puts the value V into X0, issues an MPI win order for writes, and then puts a signal value into X1, and then performs a flush. So ideally, this is all communication is done or completed in the flush, and then on process B, MPI get on X1, and then ordering for reads, and then a get on X0 and the flush. And if the first get yields 1, so if the signal yields 1, then the second get is guaranteed to yield the value V that was put in there by process A.
So I have a question here.
Yeah.
What does line, I think 27, 28, window location, what does it mean?
That is where the location of X0 and X1 is. I think I kind of copied that from other examples.
So this is not the third element. This is like definition of an array.
Well, yeah. Maybe I should call it X and Y instead of an array. Yeah. Problem is
Okay,
that I wanted to avoid having the impression of 2 windows, because then the ordering doesn't apply anymore. So that's why I chose X2. So yeah. Okay, that might not be entirely clear. Yeah.
So also X0 is the value, and V, what is V is the value. V is the value, and X0 is like what's not clear for me in this example is when you do win order and you do X. I think you're saying about like X is just a window.
Yeah.
Like when you do win order, can you specify a specific address that you want to order the access, or it's like the CPU barrier where it's not bound to any particular address, it's just the whole CPU barrier?
No, here, yeah, no, the MPI win order is bound to a particular window. Yeah.
But not the address inside the window.
No, not an address inside the window, yeah.
Okay.
But
you still want to say that you only order overlapping accesses.
No, those are not overlapping.
So access to X0 and X2, they are not overlapping, but you still can enforce the order.
Yes. Yeah.
Because I think I heard in the description that you said that it only affects overlapping regions.
No, it depends on the type that you pass. There is here on this example the win order write, which means that all writing RMA operations will be all writing operations will have to end before all the writing operation that happens after the order will begin. But there is no need to overlap. There is another value, which is win order depend, where you can order things that overlap. So that's not the same. There is
so it's like CPU memory barrier, very, very similar, right? But I think so can you go back then? I think there was some mention in the description that you mentioned overlapping regions. Maybe
Yeah,
maybe
so the order depends.
This one.
order depend. Okay, so
Yeah.
applies
The
to
order.
data dependent read and write operations accessing the same overlapping. Okay, so it's just one of the types. Okay, then it makes sense because I had impression like the whole thing applies only to overlapping regions, and I was wondering how you can track that. It's not going to be easy. But if it's just one of the options, then okay.
Okay. Okay, so I'll read that text as well. To ensure that the signal put into X1 is written at the target after the value V is available in X0, the ordering of writes has to be enforced on process A using MPI win order. Similarly, reading the value X0 on process B must happen after the reading of the signal variable X1 to ensure consistent results. Without the calls to MPI win order, the put and get operations may happen in any order. Alternatively, the calls to MPI win order could be replaced by calls to MPI win flush, which might increase latencies on both processes.
Okay.
And so this example was a little more controversial, I guess. The following example illustrates the usage of MPI win order to explicitly order RMA read and write operations from the same origin to the same target to ensure reading of consistent data after the put. Again, X is the window location on process B, and process A puts the value V into X, then calls MPI win order with win order depend on that window. So this needs some fixing. X is both the location and the window in this case. And then performs an MPI get, again, calls MPI win order, and then puts a value U into X, and then performs a flush, and it should be guaranteed that the get yields V and X contains U at the end of the flush. The ordering type MPI win order depend is used to ensure that the get reads the value of the previous put. Without the ordering, the get may return either U, V, or any value previously present in X. Yeah, it might not be entirely clear why you would want to have that. For us, it's since we're implementing a PGAS abstraction on top of MPI, it would be helpful to avoid as many flushes as possible and have MPI do the ordering without actually waiting for completion, because we don't have any control over what the user does, where he writes and reads. So if we can ensure ordering, we can more easily implement a memory model on top of that.
So I have a question. So you faced that in practice, that there was inconsistency, or you just based on the description in a standard, you were flushing just to be on the safe side. I'm just curious if the current implementation is not doing that already.
I have not checked that, but we cannot rely on it.
Yeah, that I understand. I just see if the current implementations are already doing that, then this will be almost no op. Introduction of this thing will be almost no op from the implementation perspective. But yeah,
I don't know if Jeff can comment on that.
Yeah, I assume that you're right that for the verbs and for UCX it should be already guaranteed. But I wonder how is it for other implementations? Are they more relaxed or not?
Yeah. So my feeling is that there may be networks with dynamic routing where operations may overtake, and then you lose the ordering guarantee.
Yeah, but because verbs guarantees you that, I don't think that dynamic routing, at least at Mellanox, it can break that.
Now, verbs only guarantees it if you set the send flag. Well, I don't know if that's true for, yeah.
If you set what?
So in verbs, there's a flag that you can set called fence. Thank you.
Thank you.
Yeah, okay. It feels like I'm not really prepared to talk about ordering now, but I will definitely get into that because it sounds very interesting to me.
It would be interesting to get an opinion from Mellanox on it.
Yeah. I understand. Yeah, I will take it internally, and we'll definitely get back to you through the ticket.
Okay.
What is this? What is the status of this ticket? I don't think you were reading it, or did you?
No, there was not enough time in Chicago, and we decided to drop the reading and do this in a virtual meeting because it's really early on, and there were some discussions in the RMA working group, but since I want to have it, I decided to push it. Yeah, that's the status. So this is far from being anywhere to vote on, I guess.
Okay, and you said that your particular application is the PGAS implementation on top of MPI.
Yeah.
Okay, this is where you need it. Okay. Yeah, I think it looks good to me. It basically reflects the semantics of what we have in CPUs right now. So I mean, I think it makes sense.
Well, I was thinking about changing it to acquire release semantics because I think they're slightly different in that they both include read and write in different configurations.
Okay.
But there was an explicit request for differentiating between read and write in the ordering.
Yeah, but the way I understand that you can implement acquire release with this thing. There is a way to implement, like, this is a lower level thing that allows you to get flexibility, because I think with acquire release you might have more, you will have to implement more functions or more options, if I'm not mistaken. Yeah, this looks good.
Okay, there's some more
so
minor
so
changes. Sorry. Yeah.
Order depend is only for the local process, or it can be applied to arbitrary ranks?
It can be applied to any rank. Yeah. So
Okay.
the idea was that if the remote rank, the target rank is on the same node, then you still might get around using any barrier because the CPU will ensure correct ordering. But you will still need something in the network if the target rank is on a different node. So that's why there's the difference between depend and full, right? Or right.
Okay.
Okay. There's some smaller changes in later parts. So here, when the standard talks about ordering of accumulate operations, I added the word implicit here for the ordering that is guaranteed by the info key for accumulate operations, and then down here basically mentioned that explicit ordering can be requested using MPI win order. So that's a minor change. So this sentence here is extended Note that the above ordering semantics apply only to accumulate operations, not put and get, to overlapping memory regions. Put and get, as well as accumulate operations to non-overlapping memory regions within an epoch, are unordered unless explicitly ordered through calls to MPI bin order. Okay. And yeah, I don't know. Okay, so here all of this should be highlighted. I think the latex macros don't play well with that, with the table.
So
and then there's a changelog entry. So yeah.
Can you go back to changes to the additional sentence you had about explicitly ordered except for this one? I find this a little bit misleading, I think, because when it's a call, right? The call has semantics. If you do the call, yes, you get that. It doesn't mean that everything is ordered, because just a particular thing, when you do the call, only at this point you have a before relationship suddenly, right?
Yeah.
And so, I mean, I would just take the sentence out, because I think it leads to more confusion than it helps.
Why is that? Why? I don't understand why this is confusing.
I mean, it's an explicit call, right? I mean, yeah. So it's like we have in other things too. There's an explicit call. We don't really just talk about implicit ordering then, right? So a message overtaking is not done because what happens can't happen 2 calls after each other, right? I mean, I don't think we need to mention a particular call here. And the thing is, you're not ordering all accesses, right? You're only ordering particular sets of accesses here. Putting them into the overlapping regions with a network are unordered. They still are unordered. Everyone before the win order is unordered, and after the win order is ordered, right? Win order doesn't imply an ordering on the window. It just puts a kind of a local barrier in there. So I don't think we should call this orders. I think this sentence could actually lead to more questions than it helps answering.
The reason why I added this here is that this whole section is about ordering, and I thought leaving it out is kind of strange. So if we discuss ordering, all the types of ordering should be included, but I can take it out, yeah.
And if you want
or
to
maybe
have
rephrase it.
I would say something explicit, right? Calls to win order allow ordering of like putting in basically a local ordering between 2 sets of operations, but you're not ordering the access in the window, right? You shouldn't really make sure we don't portray that image. And perhaps I'm seeing this a little bit too. If other people think this is I'm overreacting here, that's fine. But I'm just worried that people will just read this section and will think, oh, I can call when order, now I have an ordered window.
Okay, I understand. Okay.
So I have another question. So you say this is a local thing, but actually, like semantically, it's going to be a not local thing. If you want to enforce the ordering on the remote rank, then the local NIC cannot control that. Like in general case, because it will have to ensure that remotely this is done in the right order. So so I think you mentioned that this is a local operation.
Yeah, and the intent is that so this does not rely on any action of the remote site or any action of the application on the remote site. I think this is how local is defined in the semantics.
Yeah, I think you're right saying that local means it completes without waiting for reaction from the remote site. Yes. It's just you somehow need to program the local NIC to instruct the remote NIC to preserve the ordering. So yeah, that's the local operation. Now I agree.
I actually don't know how. I mean, I guess that's a question for Martin maybe, or someone from the terms chapter. How when flush is defined in terms of local, because ideally it doesn't involve any actions of the remote side. But it might if it's two-sided, so if it's mapped to some form of active messages as well.
I think flush is something like flush. Yeah, flush. But it might require. Yeah, go ahead, Martin. Sorry.
Sorry, we should take a look at the sheet that Dan and Rolf and those guys have put together, where they list every operation and the semantics, right? They went through the standard and looked at that. I don't know what that.
Okay. Yeah, just to align the usage of local with what is will be coming up.
I think it's a very good question, but I really don't know what they came up with. But they did a thorough analysis of everything, so you might want to just look up the table.
Okay.
Sorry, Arden, did I interrupt you? Do you want to say something? Want to add something else?
No. Yeah, I was thinking about flush. Yeah, it might require you to, if you want to guarantee that everything is completed, it might require you to do some remote action for some of the hardware.
Well, if it's just the hardware, it doesn't. I think we can still call it local, but I will check the terms chapter and maybe talk to Rolf.
So I think for ordering, yeah, you're right. If you say that ordering can be, like, if hardware doesn't support that, then you will need to use flush. Then probably, yeah, it might not be local. So yeah, so this is something to clarify.
Okay. Okay. Are there any other comments, questions? I will incorporate the comments and think about what Jeff suggested about the analysis there. I hope I can get this done. Well, yeah, hopefully I can get this done until Zurich. But I think so far that's been quite a valuable discussion.
So you have what you need for now from the group?
I think so, yeah. Yeah. I might need some help with the analysis that Jeff suggested, and it would be great to get some feedback from Mellanox or any other hardware vendor.
Okay.
Okay.
Anything else?
Have a good day or evening.
Sounds good. Thanks, everybody. We'll talk again next week. Tools and init and info before init next week. Thanks,
okay.
Everybody. Bye-bye.
Bye, everyone. Thank you.
Okay, bye. Thank you.
Right.